Imagine the end of everything, the universe as we know it, ceasing to exist. Chilling, isn't it? It's a concept that has intrigued scientists and philosophers for centuries. Theories have been proposed, debated, and discarded, yet the mystery persists. What will happen when the cosmic clock stops ticking? Will it be a grand finale or a quiet fade into nothingness? Today we're going to explore 5 of these theories, each more intriguing than the last. Get ready to delve into the fascinating world of cosmology as we explore 5 theories about the end of the universe. The first theory to consider is the Big Freeze, a chilling finale for the cosmos. Now, let's dive into the icy depths of this hypothesis. Imagine the universe, vast and infinite, continuing to expand. As it does, all matter and energy become increasingly diluted. Picture a pot of soup on the stove, steadily simmering. As time passes, the ingredients spread apart, until what was once a hearty stew becomes a thin broth. The universe, much like our hypothetical soup, dilutes over time. Eventually, it reaches a state where all matter and energy are so thinly spread that no new stars can form. The lights of the cosmos slowly fade, and the universe descends into darkness. This is the Big Freeze, a silent, cold end to everything we know. So the universe might end not with a bang, but with a whimper. From a freeze to a crunch, the universe sure knows how to keep things interesting. Welcome to the world of the Big Crunch theory. This theory is a dramatic contrast to the Big Freeze. Instead of an eternal expansion, the universe, according to this theory, might have a different fate waiting for it. Imagine the universe as a cosmic accordion, expanding and contracting over billions of years. In the Big Crunch scenario, the force of gravity becomes the conductor of this cosmic symphony. It halts the expansion of the universe, and then, just as a pendulum swings back, the universe starts to contract. Planets, stars, galaxies, every speck of cosmic dust, all are drawn closer together, hurtling towards a singularity. The universe, in its entirety, collapses into a single infinitesimal point. This is the Big Crunch. In this case, the universe might end in a fiery collapse, a true spectacle to behold. If the universe doesn't freeze or crunch, it might just rip itself apart. Now let's dive into a theory that sounds like it's straight out of a science fiction movie, the Big Rip. This theory suggests a future where the universe's expansion doesn't just continue, it accelerates. And it does so at such an astronomical rate that it begins to break down the very fabric of the cosmos. Imagine a cosmic tug-of-war with galaxies, stars, and even atoms on the losing side. First, the galaxies would be ripped apart as the space between them expands too rapidly for gravity to hold them together. Then the stars and planets within those galaxies would suffer the same fate. Ultimately, the atoms themselves, the fundamental building blocks of all matter, would be torn asunder. It's a chilling prospect, the universe transforming from a vast, vibrant tapestry of galaxies and stars into a dark, scattered sea of particles. The universe in this scenario would literally tear itself to shreds. Lastly, we visit 2 theories that imagine the universe in cycles: the Big Bounce and the heat death. In the cosmic dance of the universe, the Big Bounce theory proposes a repeating performance. Picture the universe as a cosmic accordion, expanding and contracting in an eternal rhythm. This theory suggests that our universe is just one phase in an infinite cycle of big bangs and big crunches. Instead of ending with a bang or a whimper, the universe would simply bounce back to a hot, dense state and start anew. The beauty of this theory lies in its cyclical nature, the eternal recurrence of cosmic life and death. On the other hand, the heat death theory paints a different picture. This theory sees the universe not as a lively dance, but as a slow fade into darkness. As the universe expands, it cools and its energy becomes more spread out, leading to a state of maximum entropy. In this scenario, all processes cease. The stars burn out, galaxies drift apart, and the universe as we know it becomes a cold, lifeless void. It's like the universe is slowly running out of usable energy, and eventually, it will come to a standstill. So the universe might end in a repetitive cycle or in perpetual stagnation. Thus, we see that the end of the universe is a topic of intense debate and speculation among scientists. We've journeyed through chilling freezes, crunching collapses, ripping expansions, bouncing rebirths, and heat deaths. Each theory paints a unique picture of our universe's finale, yet the true destiny remains shrouded in mystery. It's this enigma, this cosmic puzzle, that compels us to keep probing, keep questioning. While the end may be inevitable, the journey of uncovering these cosmic mysteries makes the universe all the more fascinating, don't you agree?